Hi, good morning, and thank you for joining me. Your first day of April here, and wow, okay, summer is definitely coming. So I'm going to be probably changing a couple more capacitors under here, but before doing that, let me offer an apology for the very long video I just posted. An hour and 40 minutes of me poking at a capacitor. Maybe a little hard to take, but that's what happened. I tend to not edit my videos unless something really egregious happens, and usually that's a video problem, like I didn't record the sound or something like that. So pretty much whatever happens here you get to see. Now I'm really not finished with that whole issue of the hot chassis, and let me just be really clear now, because so much went on in that last video and I probably misspoke a number of times and whatnot. I would call this a warm chassis radio, not a hot chassis radio. Hot chassis radio, the power cord is attached right to the chassis, one side of it. So you plug it in wrong, or you plug it in a certain way, and this thing's got 120 volts on it, right from Niagara Falls. So that's bad. This is a later version of that, where instead of the direct connection, there's a capacitor and a resistor here. Still has the same beneficial electrical effect of stopping any interference that the floating piece of metal might cause, while preventing the electrocution that could be lying in wait for some innocent person. So that's this kind of radio. So it's not quite as dangerous, provided the capacitor I was looking at is good and not shorted, and the resistor, what's that resistor doing there? I still don't quite get it. I couldn't find any direct reference explaining specifically why there's a resistor in parallel with that capacitor, although I bet you know. Well, maybe not you, but the other you may know. What I mean by that is one of you viewers is going to know why that resistor is there, so write it in the comments. Help everybody out that way. So I'm believe it or not, I don't know everything. So one of the things that happened yesterday was I discovered that this switch, which I've always been suspicious of, and why I've never used this probe, by the way, because I never really investigated what's going on with it. I was never convinced the switch worked. Yesterday convinced me absolutely the switch does not work. And so this probe has a resistor in series with it all the time. And as I discovered, this is to prevent sticking the probe on 120 volts and whacking this meter and bending the pointer or breaking it, burning out the coil, whatever might happen. So it's a safety feature. It's a safety probe, but that's not quite what it's talking about. So with this protective resistor in there, all the readings jump back. All the readings are false. In other words, you can't read this scale. Now, I think I took a couple readings, and wow. I need to stop this. We should stop this. Stop doing this. So what I'm wondering is, yeah, I can draw enough current to make that meter go up, even with the radio's not turned on. Even, isn't that wild? The radio's turned on actually. There's no power being supplied. How can this possibly be happening? I'm going to have to say I've forgotten what I did in my little switch panel so many years ago. I thought these are double pole, double throw switches. So when they're open, like they are now, there's nothing coming down here. But maybe they're only single pole, and I'm mistaken. And in fact, there's a connection being maintained, a single wire connection back to it. It must be the case. Oh, live and learn. Too much time has gone by, I can't remember what I did. I have trouble remembering the next day what I did. So what I'd like to find out now, though, can you get a real hefty shock off this? I don't think so. I don't think it's possible at all. So to do that, I'm going to plug this into a real outlet. And then I'm going to take this crappy meter, which represents us, and I'm going to see if the chassis can power this crappy meter. Put this over to 150 ohms, 150 volts rather, AC. Does this meter even work? Honestly, I don't really know. Maybe we could just take a look at that first. Plug is out. Okay, liven this guy up. There you can see you can't see what the meter's doing. Don't fall out of there. I'm going to have a closer look. So even though there might be enough power to operate a very sensitive meter, and it may look like there's something serious, some serious voltage there, and the potential for an injury to occur, I guess you can see it like that. That's not necessarily the case. This meter requires a fair chunk of current to operate, much more than the other one. Let's see. Okay, so I'm checking again. This is the outlet. So 115 volts. Yeah, that's about right. This is about 120 or something. How accurate? This can't be accurate. So now I'm going to plug the radio itself into a regular grounded outlet. At this time, this becomes a little bit dangerous to me. A little more dangerous. Okay, I'm going to plug it in. I think it's going to come on too. Yeah. So it's come on. The little light has come on up here. That's okay. No, see, I've already grabbed it. I did not get electrocuted. You didn't hear me yell or anything, so nothing's going on. But then again, I am insulated from ground, so I can afford. I'm like the bird on a wire, right? Birds don't get electrocuted as long as they don't, stand on two wires at once. So I'm gonna put one probe. I'll put the black probe. Doesn't really matter. Right into the, I'm going to do this. I'm going to get a clip lead. I'm going to clip it onto my bench ground wire here. So I'm grounding this to the power system ground over here. I'm powering this. I'm clipping this to my power system ground. Not that, this. Now the question is, what's this meter going to show? Oh, not much to you unless I do this. Okay. Well, there's enough here to power this meter. Really, can you get a shock from that? I'm going to take my shoe and sock off, stick it, grab onto a water pipe and grab onto that chassis. Find out for sure. No, I'm not going to do that. So I'm afraid for me this is going to continue to be a question. Unless I come up with an even better way to try to... well, I know another way. It's really awkward. Let's try it. Can you light a light bulb? Can you light a light bulb off that? Everyone's yelling no, no, no. Yeah, you're right. I'm sure you can't. I mean, if this light bulb comes on, run for the hills. Is this a good light bulb? I'm not sure. How do we know? Grab a meter. Checking the bulb. She's good. Okay. Can you light a bulb from the chassis of this radio? The answer is going to be no. The answer is no. Makes a lot of scary sounds though. Now you can't see this, but there are wild sparks coming off this. Let me show you this. This is something worth seeing. These are sparks without any current, or very, very little current. Oh, is this dark enough in here? See them? You can see them there. Now why isn't that blowing everything up? The 220 ohm resistor is restricting how much current is flowing, and it's kept to a fairly low amount. Why the fantastic sparks under this kind of condition? I think part of it is we can do this and see them and look at them. If this were a full-blown short, there'd just be one whopping spark and I'd be halfway out the door before you know it. So we don't get to really sit and observe what's going on. But these make very sparky sort of sparks. Sparky spark. I guess all sparks are sparky. To make it more exciting here. We'll make it so exciting to the point where I've set myself on fire. Watch this now. See, they're pretty large, eh? I'm not concerned doing this. Now with these radios, if you're fooling around them, you're going to encounter this perhaps. Now, this is why I say, hey man, don't put that radio, don't hook up a Bluetooth to a radio like this. If you know what you're doing, you can get away with it. So what I'm going to do, I'm going to reverse the plug now in the outlet. Okay, radio doesn't really care, I don't think, too much. Now, should I just go like that? No, do the whole thing over again. We start with the El Cheapo battery meter. Can you see that? Yeah. Yeah, the camera compensates quite nicely for the low light. But probably my frame rate has dropped way down. Okay, so still plugged in the outlet, reverse the plug. What do we get now? Let me clip this on the ground. Now we get nothing. You see, you can plug a radio like this in. Do this test. Say to yourself, no, there's nothing on the chassis. There's nothing. You won't get any sparky stuff if I try it. The radio doesn't even crackle. A little bit. So you could convince yourself, hey, this is great. Let me turn it off. Do you see the sparks? A little hard to see because I have too much light on again. Sparks. Sparks flying. Why? As I turn the radio on, let me turn it back off. Oh, I gotta put a knob on here. Not strong enough to do it. Okay, just grab a pair of pliers here. It's very dark in here. Did I get it turned off? Yes, okay, so I think it's turned off now. Sparks? Still sparking. Okay, so this demonstration just went down the drain. Yeah, let me turn some lights on before I get myself in trouble. What I was trying to show there was you can convince yourself the chassis is safe. No voltage on it with a voltmeter. But then 2 days later you plug your project back in, only you reverse the plug without realizing it. And presto. You're really exposed. There was a time where if I worked on a radio like this, I had a small light bulb, a Christmas tree light bulb, a filament type light bulb, and I just put it in series with the chassis over to the ground and just had it kind of different. My old house where I used to live had a light hanging here, and if at any point the chassis became live, the light came on, and that saved me a couple times. I don't do that now because I have a isolation transformer. Yeah. Unplug it here. When it's plugged in my supply here, it's in an isolation transformer, and the earth connection disappears. I mean, it doesn't mean anything. Okay. So, what did I just show now? I don't know. I showed that you better keep your voltmeter handy and be testing. Any time there's an issue around this hot chassis thing. And I suppose even a radio with a transformer could develop a hot chassis given just the right kind of failure inside it. And I don't know, is that really true? I don't know, but something to keep in mind. A meter will keep you safe. A meter will set you free if it tells you the truth. So, that aside, got a new capacitor in here. Left the original resistor in just fine. What to do next? So there is another large capacitor in here. Let me tip this up a little bit there is another big guy here. We could look at what he's doing. And there's 1, 2, 3, 3 more. 3 more. Each, I think each capacitor I've tested, has it not been bad? The big one was bad. At least the leak seemed bad. Well, I'm just going to stop and think a bit about it before I go ahead, because the owner of this radio wants it to remain as original as possible. And I've mentioned that really what you're aiming for in that is, oh, don't do that to the antenna, is what the top looks like. That's the part you see. This part underneath you never see. And I've also told her, from my point of view, what I think I'm doing is I'm not trying to maintain the components, I'm trying to maintain the circuit and its function. The circuit itself, regardless of the components, is a production of 1940 or something like that. It represents an engineer's thoughts and a company's ability to build something like this. And just because some of the parts have been changed, that doesn't change. It still is the same circuit operating the same way. So I'm quite comfortable with replacing parts here and there. Up on top, a little different. Different people are concerned about different things about these old radios. So I'm going to stop for a bit, then I'll decide what to do. Change them all, change a few. I'm going to change them one at a time anyway. Yeah. Okay, one at a time, that's a good idea. Let's go after the bigger one here. It's hooked up to the terminals of the rectifier tube. Let's see if we can find it. And I'm looking to see the size because I can see it here. It's a 0.05. It seems so physically large for a 0.05. We don't really have a parts list. You know what I just saw? Hey, we've got a voltage table here and a resistance table. Well, we may make use of these two tables. Somehow I hadn't recognized that they were there, even though they've been in front of my face all this time. Funny how things can be in front of you and you just don't see them. So a 0.05, no parts list, and 0.05. There's a 0.05. Just quickly looking to see, there might be another one in here. All the other capacitors look a little smaller. 0.005. I've already done that. I've done this. Didn't I do that? I have not done that. I have not done the volume control capacitor. This one here. I haven't done this one yet. So yeah, I don't see any other 0.05. Just this. Oh, here's one. Hard to spot. There it is. This is the one. It's right on the rectifier tube. This is the AVC capacitor here. This one, what's it doing? It's going from the... I don't know if I'm going to be able to explain what this one's doing. Is it kind of across the power line? No, not really. It's on this side of the tube. It's on the far side of the tube. Don't know. Yeah, I don't know what the purpose of this is exactly. Would appear to be I don't know. It would appear to be I don't know what this one does. So I'm going to change it. It looks like it's in a pretty important place. It's coming right off the B plus here. See, if I went to the chassis, I would say, oh, it's just another capacitor paralleling these ones. These guys are electrolytic capacitors, and they don't work very good at higher frequencies. So sometimes they will parallel it with a regular capacitor to quell any RF that's traveling around on the B plus line. This is the B plus line here, going up to the plates of all the tubes. So perhaps that's what this is doing. And they've connected it. It's kind of odd. They've connected it to the center tap. Yeah, there's stuff going on here I don't fully understand. What's up? You can see how the light bulb is connected to a tap. I said center tap, but this is not in the center. It's off to one side, designed to produce about 6 volts here. out of the 35 that's dropping across it. So that's what's going on there. And so yeah, I'm not going to say any more because I don't know what I'm talking about. I have a tendency to say things just because somehow my mouth remains connected to my brain no matter what I do. Okay, let's just change that and be done with it. It's on pin 8 and pin 3. Pin 8 and pin 3, and just be absolutely sure I'm looking at the right thing. Pin 8 and pin 3. So here he is here. I'm going to count, so I look for the key. Yeah, pin 8. Yeah, this is on pin 8 and 1, 2, 3. Pin 8 and 3. For sure, that's what this is. Sure appears to be in good shape. Let's take it out of there. Funny that they have it up so high on its leads. I think that's for a reason. Why don't they have it down close? Or a lot of radios, they try to lay these parts right up against the chassis. Like this one is down low, not quite up against the chassis. But all of these are just in the air. It's a cheap. What we're seeing is the manufacturer trying his best not to spend money on the radio he's building. Because in the store, these radios are all quite similar. The look was very different, but the operation was very, very similar, so pretty hard to distinguish yourself just on performance. They're all very similar performing radios. Okay, let's put this on the tester. For some reason I was cleaning the leads. So I'm just operating on a subconscious level here. I'm an autopilot here. You ever wonder what percentage of our actions, our functions, our behaviors, all that kind of stuff is being guided by our conscious mind, and how much of it is being guided by brain functions we don't know anything about because we're not aware of them, we're not conscious of them? And I'll bet you that ratio is like 10% conscious and 90% unconscious. I'll bet you. Okay, here we go. 50 volts. What do you say? Oh, it opened right up beautifully. Look at that. What's the rating on this guy? How high can we go? 600 volt 1. Let's give it the works here. 150. Opening right up. I put this back in the radio. 250. Very, very few capacitors coming out of these old radios can do this, what this one's doing. It's good enough we can read the capacitance using this. Let's try that out. It's supposed to be, it's a 0.05. Let's see what this machine says. Okay, so I swing this dial until the pi, till the pi shows up. Right there, let's just go everywhere just to make sure. Right here. Now we look under here. What scale am I on? I'm on the 0.5 scale, so that's the center scale. 0.001. Maybe I'm not on the same scale here. You know what? My pointer here is in the middle. It's not. Which one is it? That's off. R1, 2, 3. Yeah, you know, I was on the wrong setting because the pointer's a little off. Okay, let's try this again. There we go. Okay, it's opening up here. So now I'm on the scale that has it's 0.001, so I'm on the center scale here. So 0.02. So right here it says 0.05, and this is a 0.05 capacitor. So no leak, and it tests as a good capacitor. I should put it back in. Luckily they left long leads there, as I pointed out earlier. I can put that right back in. And you know what that says? Don't bother with the rest of them. There's no indication of need. And I've just tested a big one, and it tested really good. I think that's probably the next thing to do. Let's do this. We'll do this. So put the capacitor back in. Stick them back in, and operate the radio. See how well it's performing. Perhaps we're done. Maybe we're done. You can test the voltages. Have that beautiful voltage chart. Yeah, why don't we take that approach? Let's do that. I'll put this capacitor back in. It's like literally the first time I've taken out a capacitor and put the same one right back in. We'll try to keep it as original as possible. And then we'll make use of that voltage chart. And we can go through the radio and check the key voltages. Good idea. So let's take a look at this chart in case you've never seen one before. So it says voltage readings. It has the 5 tubes listed here, and then it has each tube pin across here, and then what voltage you should find when you test for it. Often these say what kind of meter. Yeah, look over here. Taken with a vacuum tube voltmeter. The reason they're telling you this is so if you are using a different kind of meter, and today this is not a concern, but back in the day, guys had clunky little meters like you saw that one. It was that battery tester I had out earlier. They had clunky little meters that did not work nearly as well as this. So this guy's going to pick up 90 volts, but a crummy meter might read this at 80 volts or something like that. So they usually, when they show a chart like this, they usually tell you what instrument was used to take these readings. Okay, so what we're going to do is we're going to avail ourselves of this information. We're going to go one tube at a time. We're going to just go around the pins and see if they really do match this up. And that's pretty interesting right there. That is a pretty interesting thing. Look, it's got a symbol here. What's the symbol saying? Oh, this one reading taken with a vacuum tube voltmeter. Well, my guess is they're all vacuum tube voltmeter readings, but this is the one that would probably not come out very well if you used a crummy meter on it. In the minus 13, the minus suggests a bias voltage. Now, where would you get minus 13 volts in a radio like this? This is probably a self-developing bias on this tube, I'm guessing. And in that case, it's very weak in the sense that most meters would draw the charge away when you went to read it. There isn't much pumping this up, so to speak, and you can deflate it with your voltmeter pretty easily. The vacuum tube voltmeter will show this number. The true voltage here could be different again. It could be minus 20. Even the vacuum tube voltmeter could be pulling it down into this. But nevertheless, if you use this kind of meter, you get this kind of reading, everything's okay. Even if it is pulling it down and you're not really seeing the true voltage. Okay, enough said. Let's do this. Okay, here we go. So we're going to be using this meter. We've already connected it to the B minus connection. Oh, this isn't long for the world, is it? Okay, and we're going to be starting on the top of the chart, which is the 12SA7, which is the one we were just discussing, and the 12SA7. And I want to get that. I'm pretty sure it's this guy way out here, but somewhere there's a tube chart on the bottom of the cabinet. Whoops, I can take a look at it. Bottom. 12SA7 way out on the wings. And rectifier there, so they're just marching along like that. Marching along. Oh, this is interesting. That sound you heard was the base plate falling on the floor. Now look, I never look inside of it. Look at that. Look at that. So look, that's wax dripping off. Dripping off something. So this wax appears to have come from this capacitor, the one I just put back in. And this wax, who knows, it came from here, it doesn't look like it. Probably came from the capacitor that got replaced here. That tells you something. That tells you these components were getting hot enough for the wax to melt off. Now, why were they getting hot? There's 1, 2, 3 tubes packed in here. And one of them's the rectifier. And one of them's the output tube. These are hot. There's just a lot of heat in this area. And that's probably what happened. It just, the radio was played for a long time, maybe in a hot circumstance, on a hot day or something like that. This might have all happened just in one event. Might have done that. Who knows? We don't know. Does it ruin the radio? No. We know the radio didn't get ruined from that. Okay, so I'm going to be doing this tube out on the wings here. And I'm looking for the key. The key is there. The radio's not on yet. So this is pin 1. We're starting there. 1, 2, 3, 4, around we go. Okay. What do I have to turn the radio on. That's what I have to do. There we go. I'm going to run it on its proper voltage. 118. When the radio sound starts coming in, that's when you know the high voltage is developing in the radio. Now that the rectifier has warmed up enough, these filter capacitors have charged up enough, the B plus voltage has come up enough. When at the same time the heaters are heating up, but I think they're quicker because all the tubes are heating up. The rectifier can't produce the high voltage till it's hot. So I think that's what's going on, is that as the sound comes in, the high voltage is cast through the radio. Let's start with that. What is the voltage here? What is the voltage? Just to see. Okay, we're looking at one end of the capacitor here. So that's the 150 volt scale. So you're looking at 90 volts. That doesn't sound very high. How about the other one? Take a look at the other one. That's higher. There we are. Wow, that's pretty high actually for these radios. That's 120. That's good. That's all normal stuff. Now, we'll go on the first tube. I'm going to hit the first pin. What's the chart say? The chart says 0 volts, so we'll skip pin number 1. Pin number 2, yeah, pin number 1 is usually often just a grounding sort of thing. Pin number 2, 39 volts AC. We're going to skip that. Well, let's do it. Why not? I just have to do that. They don't normally test the voltage, but these tubes are in series. If one of the heaters has gone funny, then the voltages get all disturbed. So taking one test here might be enough. 39 volts, and that's back to the B minus on pin 2. 39 volts, eh? So 39 on the 50 is going to be right about here. It's nowhere near it. Oh. So when you do AC measurements with this device, you have to throw this little hidden switch here to AC, or you're going to end up with a bad measurement. There we are. So that read 38 on my meter. 38. And the meter could be inaccurate. So that's good. Just doing that one kind of suggests they're all kind of in balance, as you would expect. Okay, next test is 90 volts DC. Let's go back to DC. 90 volts on pin 4. Okay, we got 1, 2, 3. What happened to pin 3? Pin 3 is 90 volts also. So this is pin 3. Interesting, I went dead. So on the 150 volt scale, that's 100 volts. And this one, 100 volts, exactly the same. Okay, 90, 100 sounds fine to me. Next one is the minus 13 one. So we're going to flip this to minus, and we're going to reduce this to, well, we'll go 15 volts full scale, minus on this pin. This is liable to make some noise. Yeah. I don't read any. Oh. Put this back to DC. This is so easy to forget. So now we're reading again 15 volt scale, 6 volts, and the real goal is to have 13 there. But you see, my meter may have pulled it down, even though I'm using a vacuum tube voltmeter. So of course, back in the day, these meters didn't exist. The radio just get quieter. I think it just got suddenly quieter. I was picking this meter up. I don't know. Let's carry on here. So we're looking at, reading 15 volts. We'll try it with this meter. Now, this is a very high impedance meter also, very similar to the vacuum tube meter. You can't see it where I put it. Do we get the same number? Okay, I gotta clip this onto the, maybe we'll hold it on the B minus here. I think I can do it safely. So this one, see, the radio got even quieter, and now it's showing -4. It's a better meter. Well, I have a meter in here that draws almost no power from a circuit. That's under test. Why don't we do that? That meter's over here. That guy, this guy, here. We will switch them on, and we're looking at a negative voltage, and maybe it's supposed to be 13 volts. We'll let that warm up for a bit, and then I got to figure out which test leads to use and get that set up, and we'll do a test using that meter. We'll see what it says. Okay, bit of a long camera shot all the way to here. Let me just zero this up. It's still warming up. Probably let something like this run for quite a long time before you start using it, because it takes a long time to really settle. This is the negative test lead. I've got the that meter also tied into the B minus connection here. So first thing we're going to do is read the plus voltage on the power supply, the B plus voltage. So 300 volt scale, positive, so we should get an upscale reading. The other meter said this was 90 volts. This one says 90 also, and then we're going to go over here, and that's 100, and I would say that's 120. That's exactly the same as the other meter. So I have checked the calibration of this meter. All my meters have been checked. They're all good. So we can rely on this now. Did you notice that when I was making contact, you didn't hear any clicking in the radio? Let me turn it down a bit. You didn't hear any clicking, or very, very faint clicking, not like the other meters made a lot more noise. This guy draws 1/10 the power of the other meters that I was using. So 1/10. So this has an input resistance of something like 110 megohms, whereas most meters are around 10 megohms. That's the special feature of this meter. Very, very high input impedance. So this shouldn't load the circuit at all. We should see the real voltage that's there, at least closer. Let me turn it up again a little bit. Let me go on the grid now. That's a negative voltage. We'll put this on 30. So 30 volts, 20 volts, 10 volts, 0. And here we go. So you can hear the radio still get quiet. So no doubt it's upsetting it a bit. And the reading we get, that's a tough one. But on the 10 volt scale, I don't think it's over 10. Come on. This is a terrible probe. There's so much metal out here. This should all be covered. And just the point sticking out. There it is. And that is 6.3 volts. Ooh, don't slip in there. And the chart says minus 13, and we can't get there. That's really interesting. Where is the minus 13 coming from? Now, typically it would come from the AVC voltage, but there's no signal in here to generate an AVC voltage. That's pretty interesting. Let's mess around here a bit. What I'm going to do is I'm going to put I'm putting a clip lead on one of the earlier tubes. It's probably just going to introduce an awful lot of noise in the radio's operation. So I'm clipping it onto the... I don't normally do this with it live. Okay, good. I clip this here. There we go. Now I'm going to tune the radio around. I'm not sure it's going to pick anything up, but let's watch this meter. Does it go up and down as I tune around? This is not doing the right thing. It's slowly going up as I tune. I'm tuning across the band here. Okay, I'm at the end. I come back. This doesn't strike me as anything proper, but maybe I'm just... So, you know, this would generate an AVC voltage, that sound. But I don't see anything, the meter's not doing anything at all like that. That would certainly generate a voltage. Huh. We need to investigate this a little bit. We've got a voltage half what it should be, measured with really good instruments. In its day, that meter we just used, that's probably a pretty darn expensive meter. You never find that in a radio shop. That would be in a laboratory somewhere. So, let's look at the schematic and then I'll take a little break here. I can pop the schematic right up here. Yeah, we can just look at it right in this window. So what I'm doing is I'm measuring the voltage. What? I'm measuring the voltage on pin. Let me count it so I know what I'm doing here. 1, 2, 3, 4, pin 5. I'm on pin 5. Okay, wait a minute. Now pin 5, and didn't expect this. So pin 5 is part of the oscillator circuit, which I haven't talked much about yet. So there's two input grids on this tube. There's two signals coming into it. One is on this, coming from the antenna, and the other one is an oscillation coming from down here. Now this is part of a transformer. This part here. This is actually picking up signal from down here. So we're attaching to the oscillator here. This is a really difficult place to make a voltage reading. The negative voltage is coming from the fact that this is oscillating, and there's a rectification occurring, and the result is, I guess, it builds up a pretty good negative voltage here. One of the ways you can tell if an oscillator is running is to look for this voltage. But in the course of looking for it, the instrument you use can actually defeat the oscillator, bring it to a halt. So every time you measure it, there's nothing there. But if you take your measurement instrument off, it's back. It's easy to get tricked on this stuff. I thought we were working on grid number 8, or pin number 8, the signal grid. That's why I was looking for the variation in the AVC voltage, which I didn't see. Well, the AVC voltage is applied here. There, you see AVC, and it's coming out of here, which we can't see right now. Let's move it over. So the signal coming out of this transformer gets rectified right here, and they set this up to produce a negative voltage. They could set it up to produce a positive voltage and throw it all away because it's not of any use, but the negative voltage is of a lot of use. If you feed the negative voltage that develops from a strong signal back onto the grids of this tube, and this one too is probably getting the treatment. Yep. Then as you make these grids more negative, these tubes don't amplify as much. So strong signal cuts back the amplification of these tubes. Automatic volume control. That's what's going on here. So when I was tuning in little signals and expecting the voltage to vary, it's the voltage here that should vary, which we will look at next. Testing this, I almost never test this. A better way to do this, in my view, is to get your SDR radio out, get your coil out, put a sniffing coil somewhere near here, sniff the signal into your SDR, and then look on the screen, see if it's there. Tune the radio, see it go up and down. That's how I would approach the question of, is there a local oscillator operating in a radio? I'd use my SDR to do it. I wouldn't attempt this because I know there's a lot of trouble with trying to measure this voltage. We also know the local oscillator operates in this radio because the radio is receiving stuff, so there's no question it's operating. I guess you could test the voltage here and try to determine if it's operating with enough strength. If the local oscillator gets weak, maybe weak because this tube itself is weak and the amplification isn't that strong anymore, and so you're not getting the strong local oscillator, weak local oscillator, weak output from the radio. That's what happens. Weak signal in, strong oscillator, weak signal. Strong signal in, weak oscillator, weak signal. So that's the story there. If you're new to this, you may wonder, well, what's this oscillator doing in there? I haven't bothered explaining that, and I'm not going to right now. But so we really want to know the voltage here on pin 8. So I'm going to switch over to pin 8. We're going to do that AVC check to see if this does go up and down. And then I will use that high impedance meter because, again, this is a very sensitive circuit. Look at the resistance here. 3 megohms. So it wouldn't take much of a meter to draw out the current, draw current out of this and reduce the charge pressure in here and reduce the voltage. Well, we call it voltage. It wouldn't take like it. So again, a lousy meter measured here, you're not gonna get what you really want. Let's try it out. Yeah, incidentally, when I put the meters on this leg, you heard the radio get a bit quieter. It's because I was weakening the oscillator and maybe even shifting its frequency a bit. You can't really tell that. So okay, pin 8. Let's go. Pin 8. Let's go. Pin 8. Oh, all I have to do is just do this. I'm thinking you're looking at it full screen when you're not. Oh, I hope that all got on the screen. Oh my gosh. Well, I apologize if some of what I was talking about wasn't showing because I'm looking at a full screen version of it and you're looking at a piece. I'm very sorry about that. But let's move on. Let us move on to I totally lost what I was going to do. Oh yeah, the other grid. It's other grid. That's pin 5. Wait a minute. No, pin 8, Jim. Oh my gosh. 0 volts. That's not true. Well, 0 volts with no signal. Let's fool around here. We'll get to pin 8 in a minute. We'll continue on. We're here. Okay, we got some negative voltage here. The oscillator's operating. I think we're okay. Pin 6 is 0. Pin 7, 27 volts AC. That's the other side of the heater. I'm going to skip that. We'll go right to pin 8. Right to pin 8. Okay, pin 8. The radio's on. Take this off. Pin 8, eh? Well, that's way in there. Pin 8. Hey! It's picking up some signals. It's picking up some radio. I don't know if you could hear it there. I could hear it in amongst the noise. It's actually a radio station there. Yeah. So doing this, of course, is affecting the operation of the radio a bit. I'm going to put on the meter. Let's put on the meter. Okay, here's that negative 10 volts. That should be okay. Now this is probably going to knock the radio down. Let's see. Nope, not at all. Perfect. So you could think of putting this meter on as hooking a 100 megohm resistor across the I drew a blank. I've drawn a blank. It's usually time to go have a break, I think, but let's do this. So the idea here is if I tune in a signal, it will be rectified by the detector. The rectified result is then utilized by the radio engineer, direct back the DC back to the grids of the earlier tubes, calm them down because a strong signal is coming through. So if I tune stuff in, this meter should go up and down. Let's watch. We get a strong signal. Well, that's a pretty strong signal. It's a tiny movement here. I can see it a little better there. Why don't we tune in a real station here? Now let's do the real thing. I'm going to set up so we can pick up a station and we can see the real AVC voltage. Good thing to check this anyway. Yeah, so I just came in here and this started up. This interference comes around my house every morning. I have no idea what it is. That's enough of that. So I brought in this loop antenna. Now I'm not trying to promote this loop antenna, but I have bought 5 of these, and every one of them I've sold off, at cost to different people who I'm fixing their radios as a good antenna to make an AM radio work better than it will with its own loop antenna. It's tunable and that. So I'm not trying to promote this, but I just bought this one because the last one I bought, I gotta be honest with you, the last one I bought was defective. It turned out the capacitor had a short in it. I took that apart here in my shop. You may have seen me do it. That antenna is still apart. I haven't done much more with it. So unfortunately it's just turned into 2 coils. So what I'm doing, I'm going to plug this antenna, believe it or not, into my outdoor antenna. Here, have a look at what's going on here. This box is the terminal for my outdoor antenna here in the shop. And I have 3 outputs from it. I can select. This is the one I'm going to use. Oh my gosh, I just plugged it in. Just like that.
And, my other point would be...
This idea looks good. So, the weird thing is now, I've got my outdoor antenna powering this loop. The loop is tunable. We're going to tune it in a second. Now, more evidence that it's working here.
I don't know how the protesters would do in that crowd. Maybe they won't. They won't make a lot of friends. If you interrupt that eclipse, you will not make friends. Maybe you'll get to go swing in Niagara River. Very cold at this time of year.
Okay, in the meantime, not watching the meter over there. Watch this meter.
Everybody to come to your town and they called for emergency powers. Good Lord, what's going on? We'll talk about that in just a second.
Now, you notice the radio's not getting much louder, is it? The signal. Okay.
Canadians want to be informed. That's why more Canadians than ever are turning to Global News at globalnews.ca, one of the most visited news sites in Canada. On
8 volts.
Where Global News is the #1 news source in the country with the Global TV app or
tune the radio.
Global News 24/7 on a smart TV for the most extensive news coverage available on all platforms. Canada's trusted source for news. Global News. We're PC Express. Of course we do online grocery delivery and pickup.
We're PC Express.
Yeah, that's what we do. We order all our groceries through this PC Express. My wife sits with her computer and picks all the groceries we're going to buy, and then I go pick them up. They just stick them in my truck and I drive home. It's great. I think we pay a $2 charge, if even that. Okay, so what we found was with a proper signal coming in, so something decent into the radio, it's just going from here to this, the radio's antenna. There's no direct connection between them here. With a nice strong signal, we see an AVC voltage. You can see it on the meter. You can see it going up and down as I tune in and out. All working good. And now I'm must go check my phone because I just heard it go ding. Okay, let's carry on with the measurement side of things. We can just leave this playing here. As long as I don't play music, there's no copyright issue. So let me disconnect. Might get a little bit louder. Nope. Pull this out. Okay. Now we're going back to taking readings, and we're going to go back to using this meter over here because I like it. Okay, so we're on DC positive, 50 volts. I need a new tripod. Okay. Where are we at now? We're on the next tube. Next tube 12 SK7. Next tube's there. This is the IF amplifier. First voltage worth checking is really pin 6. There's really only pin 6 and pin 8 that are really worth checking. 90 volts on both 6 and 8. 90 volts. 150 volt scale. 90 volts is going to be about here. Pin 6 and 8. This is pin 8. Right there. And this is pin 6. Right there. Perfect. The rest of the voltages we're not going to worry about. We'll go to the next tube. 12 SQ7. This is the detector tube. Lots of funny voltages on it. But these are really the ones we want to look at. Actually, this one. You notice the plate voltage. That's what this is. The plate voltage is a little low. Only 62 volts. My understanding about that, and I may have it wrong, is that you raise the plate voltage, you generate more and more noise in that tube. And so to keep the tube quiet, the voltage is kept low. And that could literally be from the speed of the electrons flying through the vacuum in the tube and striking the plate. That could generate a bit of noise. Who knows? I don't know. Okay, I won't comment any further on that. So we're on to SQ7, 62, pin 6. Pin 6 on this tube. Pin 6 is, here we are, 876. This is pin 6. That's supposed to be 62. This is the 50 volt scale. It's not getting there. It's only 40. It's actually lower than that even. Okay, so we got 117 volts on the radio. Here where we expect to find, what was it again? 62 volts, so 60 volts. 60 volts would be off the scale. We're getting under 40. That sounds a little bad to me. It sounds a little low. Why don't we look into that? So that is easy to do because I can just scroll up here. I'll be more careful this time. Let me shrink it. Well, that's not the best idea either, but okay, so we're on this tube. We're checking pin number, oh my god, my memory is so bad. Pin number 6, wasn't that? Pin 6. I can tell which one's the plate. That's this tube here anyway. Let's move it over. 6SQ7, pin 6 is a plate running at 60 volts nominally, but I'm measuring it at 40. Now what would cause that? Well, it's getting its voltage through this leg here, and this is right on the voltage supply, so we know there's 90 volts here. So if this resistor wasn't here, we would see 90 volts. Now, the resistor's here, and this is supposed to be 60 volts. How much you want to bet this resistor is no longer 220? I'll bet you it's 300 now. We will check this resistor. Now this is one I've already cut away by accident and reconnected, but I never tested it. So let's check this guy out. Oh, that's right. I don't have to. I keep forgetting I've got an inset on the computer screen. So that resistor is right there, and we're going to check it out. We're going to turn this baby off. I'm going to check its resistance in circuit. As soon as I find my the meter I want to use. So I got a lot of meters in here, and you might say, why have I got all these meters? Yeah, go ahead. There's no good reason why I have all those meters. Resistance. Oh boy, I really didn't I get enough sleep last night? Actually, I did go to bed a little late last night. I was really beat. Okay. Now, could there be a little voltage there still? I doubt it. Let's just convince ourselves there isn't, though. Nothing there. If there were voltage still there, that would interfere with this reading. So we're looking at 220K. There we go. Oh my, I'm not getting any reading here. This is 600. This resistor is more than 600. Really? Oh, there we go. Oh no, I bumped something, did I? Well, this looks really corroded down here. Why would that be so corroded? Corroded enough I'm having trouble making contact. There we are, 254. It's supposed to be 220. Wow. 220, 250. Is that really going to make that much difference? Now it's in circuit. I just made that measurement with it in circuit. Now is that in any way? So if we go up this way, whoops, we encounter a brand new capacitor. So that's the end of the circuit that way. And we go this way, we have this capacitor. What if this guy's leaky? And then we have this. It doesn't go anywhere. The radio's switched off. So yeah, I can just put the voltmeter or ohm meter on here and my reading is valid. So this isn't 220. This is now whatever it was I read. Not a lot higher. On a percentage basis, it's only like 5 or 10% higher, which I think would cause a 5 or 10% drop in the voltage here, which would hardly be readable. So another possibility is this guy is leaking badly, and it's pulling the voltage down here. Similar to how hooking up a meter here might draw some current and pull the voltage down. This could be doing it. This is almost certainly a mica capacitor. It's almost certainly in good condition. But it's a big one, 470. Let's take a look at the situation here. We can find this and consider whether it might be leaky. Ultimately, the lower voltage here give you less output coming out of the speaker and less signal range on this grid before you run into distortion. So on high volumes, you might get distortion out of this low plate voltage here. Maybe. Could be. Where's that guy? Oh yeah, that's right. I keep thinking I have to flip screens around, which is a big hassle. But I don't, because okay. And hopefully you saw everything I was pointing at. So the 220. What was a great idea I just had? Didn't I? Oh yeah, check the capacitor. Okay. Wow. Ah man, this is not a good day for Jim. So here's the capacitor in question. That looks like your typical mica capacitor. Any reason to think that that is leaky? Is there any way we can test it with it just sitting right there? So we have a new capacitor here. We have a resistor going to a plate here. It doesn't go anywhere. Boy, I better not say that. There's a resistor here and all kinds of stuff. I better not say that. I'm wondering if I could just put a test right on this capacitor. I don't think so. There's just too many things hooked up here and there and everywhere. You have to open one lead of this capacitor to test it. And the chances of it being bad are very, very small. So once I open the lead and kind of test it, I'm probably going to have to replace it. And I certainly have replacements. So let's do that. What else could pull that voltage down? The resistor's a little high. Maybe I'm wrong, and maybe this a little bit of high is enough. Pull it down. I didn't read the input side of this. I assumed the 90 was there. Maybe we better do that. Better just make sure that The reason the voltage is low here is not because it's low here, which I think is highly unlikely. Okay, let's turn it on again. Back on. I got so many test leads here, or meter probes. Let's use this one here. Okay, we're operating again. I'm very, very happy this antenna thing really worked out. This can be really useful in my shop. There's no doubt about it. So we're looking for the output voltage here again. Positive 50. Supposed to be 60 volts here. What happened? It's there now. $60. What happened? I must have made some kind of mistake making the reading. Positive 150 volt scale. It's right on, it's just below 60 on my meter. You can't get much closer to 62 than. Huh. Let's read over here. This should be higher. 100.
Daddy is the mayor of Niagara Falls, and it almost sounded like it did catch him off guard that there was going to be this precaution brought in when I...
So there's a eclipse coming, and there's going to be a total eclipse visible in parts of the United States and parts of Canada, not far from me, about a couple hour drive from here. One of the areas that's going to go into total darkness, probably the best place to be, is Buffalo. Buffalo is right on the center line of the total darkness band that's going to go across. So if you're in Buffalo, you've really got a treat coming. Another great place, a short distance from Buffalo, is Niagara Falls. And of course on the Canadian side, it's a major tourist area. So on a big tourist day, some big thing going on, Queen coming, I don't know, something really big, 150,000 people will show up in the town of Niagara Falls. It's not that big a place. They expect 1 million people because it's going to be almost totally dark. It's Niagara Falls. And so they expect 1 million people to show up there. They're panicking at this point. The roads can't do it. Nothing can do it. 1 million people? Don't go to Niagara Falls. My wife and I are considering driving to a different part of Ontario, just farmland. We'll just pick a back road and park our car. If we do this, I'm not even sure we want to do this because it's a long drive. It's 2.5 to 3 hours to get there. So, okay, enough of that talk. But that's an exciting thing that's coming. That's what they were talking about on here. That's why I brought it up. Once again, I've totally forgotten what I'm doing. So somehow I got a bad reading and went off on an unnecessary journey. That's what it seems like. Let's just do it again. Although, I mean, once it gets 60, it's pretty hard. Did I have this on AC? I don't think so. I think I corrected that right away. 40. Can you see? You can't see it. It says 40 now. What happened? Oh, remember before, the radio was loud, and it went quiet, and I said, hey, what happened there? Watch. 40. That's 40. On the 50 volt scale now. That's 40. I'm watching it. See if it's drifting downwards. It appears to be drifting downwards very, very slowly. Something is slowly going wrong. Probably from heat development. Something is heating up and going south at the same time. You want to bet it's that maybe that was nothing. It's just some this guy. Hey, I got an idea. I got bottles and bottles of cold spray here. which I almost never use. Never hit a tube with this stuff. This is going to come out super cold. Okay, that's how cold it is, super cold. But we want to watch the voltage vary as I cool down that component. That's the idea. Okay, so we're going to go on here. So I'm going to clip this on to the 60 volt, 40 volt spot. Oh, 40. Okay, so it says 40. Now I'm gonna move this to a higher scale, anticipating it rising up. It's still reading exactly 40 here. 60 is here. We'll take our cold spray. This stuff's hard to direct. Let me test it. She really blasts out there. Okay, so we got to really keep an eye on this now. We expect it to go up if this part responds. You can see a thing happen. How do we know we're making it cold? You could hear the liquid coming out of here and boiling on the chassis. I didn't see any change whatsoever here. The other thing is, 40, 60, it looks like it's, two operations, not something drifting down, drifting up. Look like it went. Let's spray some more stuff here. Why not? Let's spray that resistor. No, I didn't see anything change. A couple more parts here. I'm going to spray them. I got the spray out. If anything, this is just slowly drifting lower and lower. Could it be a tube thing? Yeah, I suppose it could be. Somehow. Kind of a sudden thing. I don't think this is going to get us anywhere. Look at how cold the tip is. I can freeze some stuff off myself. I got some things I could freeze off myself. Who needs a doctor? Freeze some body parts off. Well, this is definitely a problem because we've seen it at 60 and at 40. Or is there some continuing mistake I'm making? Let's shut the radio off, we'll let it cool down, we'll turn it back on, we'll see what this is. That's the way to do it. Oh, I sat down, picked up my coffee cup and realized something. If the voltage that I'm reading is going down, is it because the supply coming into that circuit is doing the same thing? So, I want to... So where are we at? Now look, we're up close to 60 already. I was only gone for like a minute. It's drifting downwards. Well, let's read the other voltage. I'll use another meter. Use another meter. Use another meter. Lead on, because if I'm holding these meter probes, usually the reading is kind of shaky. Okay, I've grounded that meter. First we'll read the same voltage that's here. This is now below 50. What do we get? 46. 46 I think is the reading. And what we want to do is look on the high side now. Is it still all there? 100 volts, it's all there. So whatever's going on is going on either in this resistor or that capacitor. I'm willing to bet it's the capacitor, even though I sprayed it and it didn't do anything. You know, if current is flowing through that capacitor, it's going to warm up. Let's see. Now, it could be very subtle. Seeing it on a thermal viewer might be tough. But why not? I'm blown away that I have stuff like this. Okay, so everything's red because the setting's on here. So we're going to change the settings here. Okay, now this is hard for you to look at, but you know what? I'm pretty sure that capacitor is warming up. And it looks like it's at 34, 35 degrees, whereas this panel here is 25 degrees. Now it's pretty close to some heat stuff here, the tube itself, but there shouldn't be any heat in a capacitor. Can you kind of see it? This is the capacitor here. You see a little yellow blob moving around there? It's getting hotter. This one's going to smoke right in front of us here. I've had that happen a couple of times lately. You know, it's pushing 40 degrees now. And you can see other things around it are not that hot. The blue shows they're cold, like the panel and all that. So the capacitor is developing heat itself. They shouldn't do that. No, no, no. Capacitors should not develop, as far as I'm concerned, a good capacitor should not develop any heat inside of it. The voltage and the current are completely out of phase. We'll change that capacitor. Then we'll retest this thing. Okay, got a replacement here, 470 picofarad capacitor. It's a wild time in my shop today. We're gonna cut that out. I'm sure I can't forget where it came from. Wow, everybody's flying around. I don't normally try to desolder connections in here because you end up working and working and working and trying to get them off the terminals. And I think that's bad. So I just assume just leave behind whatever's wrapped around the terminals. And I didn't pull this out. Shame on me to pull that out. We got to test this guy. Let's test him with this first because it's so easy to do. So I have found, I've said this so many times, that these tests are bogus if the capacitor being tested is leaky. They test high. The test goes high. 414 picofarads. V loss 0. I mean, doesn't that sound nice? That sounds really good. 414. It's a little low, but I don't think it's significant. Now maybe you heat this up, this goes downhill. But I somehow I think I'm not finding it. Not finding it. It could be the resistor that's going high on its own. But let's put this new one in, and we know it won't be the capacitor. Then we'll know that for sure. These are highly reliable capacitors. They do fail. I have found bad ones, but right. Okay, so I'll install this and we'll test the radio again. So I may have found a problem here. It may be me. So I nipped this resistor here to test the radio, and then I soldered it back. I just tacked it back to its lead wire here. And while I was working on putting in this capacitor, this just separated. And I remember, oh yeah, it was very temporary what I'd done. Now the problem is I'm going to fix this connection. If this connection was the cause of the problem, we're not going to know whether it's the connection or the capacitor. That's unfortunate. But so many times I've tried to do things in a way that would, prove something out, and then either I realize afterwards, no, you're not really proving anything. For one reason or another. But I think it is good to have like a hypothesis of what's going on all the time. It's always good to have a plan, even if you throw the plan out immediately upon starting something, because you have a notion of what is going wrong. You have a notion of how you're getting off track from where you want it to go. But if you don't have any plan, you have no notion. No notion. We need notions. So, you know what Churchill said about plans? He said, plans are nothing, planning is everything. Very insightful. Okay, now that's a much better connection. That is not going to cause any kind of weirdness. Weird too that this kind of thing failing would cause 60 to 40 and no, that doesn't quite make sense to me. Okay, we're going to put on, make sure the meter is connected here. Yeah, you just put it right on, because possibly it's going to produce 60 volts and then drop to 40. We would like to see that happen. Okay, and the other thing we're going to do is we're going to put this on the pressure tester. Yeah, let's give it the pressure test here. Pressure being voltage. We're going to put some pressure on this. These capacitors, they even in used condition should show really good on these tests. That's what I think. I don't test many of them because I don't remove many from radios. So here we go. We're talking 50 volts. What do? You didn't even see it close. 150. How high can we go with this? Is there a rating on it? We'll go as high as we want, because what does it matter? Here we go. Look at that. There's just nothing leaking through here at all. So what could be? I don't know. I don't know what to say. Let's give it 450. Everybody stand back. Yeah. When I checked the capacitance using the other capacitor checker, and it was correct. So I think this is a perfectly good capacitor, and I think we're in the wrong direction. On now. Now we got a perfectly good capacitor in there. There's no question about that. Let's operate the radio now and see what happens. So get this meter out of here so I'm not confused, or at least less confused. Look, it could be less confused. So you want to see the meter. We're going to see the meter hooked up. Should start happening almost right away. There we go. Oh, man, it's hard for the electricity to jump all the way to here. There we go. I thought this would jump up pretty quick. Am I doing something wrong? Something going wrong here? Something not happening? What's not happening? There it goes. Heading for 60. It's stopping short. That's 55. So we're going to leave it operating there, and I will come back in a bit. I'll go drink a little coffee, and then we'll see what the voltage has done. It might take a little while now because the radio was off for a bit. We're running with, oh, not full voltage. We're almost at 62 here now, 59. So this is the high one. We'll let her run. Okay, well you can see it's dropped to 40 after just a few minutes. So the question is now, is it dropping on the other side of that resistor? Um, 150 volt scale. No, it's all there. So it's got to be the resistor. It has to be the resistor. So I'm going to freeze the resistor now. That should, assuming it's the resistor itself, what else could it be? Let's cool it down here. What happened? Oh, for crying out loud, Jim. Yeah, did I say something about usually my experiments kind of go haywire? Didn't change at all. So if it's not the resistor, it has to be the vacuum tube that's doing this. And the question could be, is it because the tube's operation is being pushed off by something else? There's more going on here. How could that be? Let's take a look at the schematic again here. Oh, it's right up here again. So here we are. So we're finding the 22. Oh my gosh, what? I just have been in here too long. Here it is. Yes, that's right. So we find the voltage here is normal all the time. The voltage here is going down over time. We've changed this capacitor. The one we took out, we tested, it seemed fine anyway. So this is not the cause of the problem. This doesn't appear to be the cause of the problem, because when I cool it off, it didn't have any effect on the voltage. All that's really left in this circuit is the tube itself. So what could be happening to the tube to throw it off? We could have a voltage building up here on this pin 2. Now if we look at that voltage chart for pin 2 of the this one, should be minus 0.4 volts. But if it got more negative, or the other way, we got to try to measure this. So this is pin 2, looking for minus 0.4 volts on pin 2. Again, it's a grid, it's difficult to measure. Okay, 12SQ7. This is the audio grid. Okay, I'm just a little hesitant here for some reason. 12SQ7. Well, that's interesting. Just my eye just went over here to this. Not that it has anything to do with what we're doing, but this part is inside the can, the IF can. And it looks like a capacitor plate here. And then what's happening with this other line here? It's this, we should, what is that? I don't know. They have it kind of bumping in here. Is that a mistake in the drawing? It's gonna be hard for you to see that, but here. Look what they're doing here. This component, the way it's shown, looks like a capacitor with 3 plates. The center plate appears to be grounded. That's quite common to put capacitors in this circuit like this. Usually on either side of this resistor, which is what's going on. Yeah, so you've got one side on this side of the resistor and the other side. Do you think that's a connection? I have trouble believing this isn't done on purpose. Otherwise, this piece here is just a line on the page. It's not connected to anything. So that's what that must mean. It's not how I would do it for sure. If it's just a wire connecting here, I don't know. Okay, that's just interesting, but doesn't mean anything. We get back to this guy here. So possibly some leak could occur through here. It would push this positive. This would cause more current to flow through the tube, and that ultimately would cause more voltage to drop on this resistor, leaving less voltage here. That could be the case. And since this happens fairly slowly, it could be a leak. It'd be volume control dependent. See, the problem here in all these radios is there's a DC voltage here. Now sometimes they block it right away. They might block it here, but in this case they're utilizing the volume control resistor right to ground as part of this DC circuit here. So they're allowing this direct current voltage to push current through here, but they don't want it to get up here. So they have a capacitor in here to stop it. Now, did I change that capacitor? I'm looking in the I'm looking at the volume control, and the answer is no. So that's the next target, because possibly some current is leaking through here. Possibly. I've got a story. Let's change this one and see if the problem goes away. 0.005. Okay. Oh, that's right. I don't have to do anything. Oh, I'm sorry. Once again, I've gone and done this with just a little window there, so I really apologize for it. I got to keep looking up at my big screen here. So this is what I'm talking about, the volume control. And there's DC coming down here and flowing through it to ground. And to keep the DC from flowing this way and getting on the grid, there's a capacitor. And now my phone's ringing. Oh my God. Okay, so I've been distracted for quite a while. Somebody wants to buy some tubes from me, so. Okay, so let's pull this out of here. We're going after the volume control capacitor, if we can call it that. And the idea is if this guy's leaking, maybe it's pushing the grid voltage incorrectly. I don't quite see how it all adds up, but nevertheless, let's just do it. This guy looks really good. It looks like brand new almost. 005. Let's see what happens. Now, in some cases, the tiniest leak in these capacitors is going to throw things off. This may be one of them. So this doesn't measure leaks at all. This is attempting to measure the capacitance. So this is saying this is a 9,000 picofarad. Okay, so that would be the same as a 9 nanofarad. That would be the same as a 0.009, but it's supposed to be a 0.005. So it's reading high. That's an indication that it's probably leaking. Okay, first test seems to support the hypothesis that it's a leak in this capacitor that is upsetting that tube and ultimately causing the plate voltage to drop. It's a bit of a story. Definitely a bit of a story. Okay, so on the leak test, 50 volts, what does the eye do? Opens right up. 150. Ooh, it doesn't open at 150. Well, maybe this can leak enough. Even though it looks wonderful. 0.005. But I can tell you in my own case, good looks, that's not everything. So I'm going to put in a new 005 and we'll repeat these tests. We'll see what's happening. Okay, new capacitor is in. Let's give this radio a test. We'll see what happens. So we're watching this meter over here. 60 volt meter. Show me 60 volts. Now it's probably going to show 60 volts at the start, and then it takes a little bit of time for it to drop back to the 40. Funny, it doesn't drop. Like, why stop at 40? Why not just keep going?
This audio for you because it's
Oh wow! I think we got a lot more volume out of that.
insanity. Have a listen.
There was a New York Times article.
That would not be surprising. All the audio is going through that capacitor. Voltage here, okay, about the same as it was before, just below 60. Okay, so we're going to leave this operating while I wander around the house, and when I remember I will come back and we'll see what the voltage is then. It's really close to 62 now. Of course, it could be 62. This meter's not that precise, or that accurate rather. Okay, see you in 5 or 10 minutes. Okay, well, look at that. It's fallen to 40 again. So the capacitor didn't help. The other capacitor didn't help. I'm going to try to read the resistance of that resistor, turn the radio off and read it right away and see what we get. A little disappointed, I'll be honest. I think what's next on the list though is the vacuum tube itself. I can't imagine anything else at this point. Okay, so we'll go on. It's supposed to be 220,000 ohms. So there we are. We are ready. Now there may be a voltage languishing there, so I think I'm going to start by checking for that. Here we go. Radio off. Excuse me. Nothing there. Okay. Supposed to be 220. There we go. This is so hard to read, this one. Oop, 230. That's not 230 flyby. Same as it was before. Oh, what's it doing? It's going up. It's going up while it cools down. That's a little counterintuitive. Let's stop right there. Maybe I just didn't have a good contact. So 246. Wow. From 220. And the thing is, it's always this resistance. It's not going up and down. And I think it's the vacuum tube. I think that's the next experiment. We'll have to change the tube. I think that's, which one is it that we're doing this with? This is the I believe 12 SQ7, I think is that one. Okay, anyway, I'll get another tube and we'll repeat all of this. Okay, so I've got a glass, like what's in there, a glass 12 SQ7. Let's give it a test. On this tester, 12 SQ7, so 12.6, A234, A234, AC18, AC18. There's 3 tests here, 50. So you wonder, well, what would happen to a tube that would cause this? And there can be internal problems in a tube of various sorts, including leaks of current between the elements. It can happen up in the business part of the tube. It can happen down in the base. Not saying that's what's happening, but something's happening. Okay, so we're ready to test this. We look for a leak, or look for a short rather. Okay, no shorts showing up. To test this, we do WX. She's good. Okay, that's good enough. I'm going to put this in. We're going to see what happens. What happens here? Okay, I'm going to get that out of there without making a mess of things here. The whole chassis is warm. I've had this on enough for that to happen. Come on out. Okay. And look, we got this sitting right on top of the antenna here. That can't be a good thing. Okay, so we still have the voltmeter connected, and we have a different tube in there now. Get rid of this out of the way. Okay, I think we're ready for another test here. Yeah, I'll make it taller for this test. That's good. Dim bulbs first. Normal operation on them. Volume is right down. Leave it like that for a moment. I don't like being surprised by the loud volume that might come out of it. Now I've got the radio antenna right up against this coil, so it should be a really good signal strength. Oh, I hear it. Ridiculous amounts of volume. It's ridiculous, I tell you. Okay, appears to be working, and the voltage is 60. Okay, once again, come back down here. We're going to leave this thing running. In fact, this time it's actually just above 60 on here. You know what? I think it's falling. Well, let's not worry about it. Could be anything. Leave it here. Don't worry about it. Don't anybody worry. We'll come back in 5-10 minutes. See what happens. So it held up. It didn't fall to 40. It stayed up pretty close to 60 where it should. It was the tube. Okay, well that was an interesting journey. Vacuum tube causing this problem. Very good. Okay, well that's it for today then. Tomorrow, who knows? I don't even want to predict what might happen in here tomorrow. So, okay, thanks a lot for watching, and see you later.